The next topic we're going to go over is systems of equations, and this is certainly a topic we'll talk about for a few days. First of all, what is a system? A system is when you have two equations or more. And in this class, we're just going to focus on two equations. And when I say, hey, solve this system, it's possible for you to get one solution, no solution, or an infinite number of solutions. And let's just cover all three of those now. In the case of one solution, you'd have two graphs that are actually just going to cross once. And this would be your answer to your solution. You would say x equals 1 and y equals negative 1.667. Or you could give your answer as a coordinate. Doesn't matter to me. And what does this solution mean? This solution means that it's the only point that satisfies both equations. Again, what do I mean by that? Well, it means if I plug x equals 1 into this equation and y equals negative 1.667, and I did this math out, 2 times 1 minus 3 times negative 1.667, I would in fact get 7. Similarly, if I plugged in 1 for x here, and again negative 1.667 here, I would in fact get 0. And that's the only point where that's true, where you plug both those values in for x and y, and it works for both equations. So there's an example of one solution. An example of no solution, change colors there, would be when your lines are parallel. They'll never intersect, so this is no solution. And so you'll see here, and if you were to break this down, that they have different y-intercepts, but they'll end up having the same slope. And we won't take time to solve those equations so I can show you that, but just trust me that these two lines are parallel. They will never cross, they will never intersect, so there is no solution. Now the third example is when your two lines are exactly the same. So if I were to multiply this entire equation by negative 4 on both sides, you'll see that you get a negative x plus 2y equals negative 4. In other words, even though it looks different, if I multiply both equations by negative 4, which I can do because I'm changing both sides of the equation by the same thing, you'll see that although it's written differently, this equation right here is exactly the same equation as this. Right, I just multiplied this one by negative 4 and this side by negative 4. All right, but it is the same exact equation, which means what? It means that if you were to graph both of these lines, they lie on top of each other. And in this case, we have an infinite number of solutions. Meaning that there's, instead of just having one point that works for both, all of these points on this line will work for both of the equations. You can think of it as crossing in every single point. So that's an infinite number of solutions when your lines end up being the same thing. Think of this as a blue line right underneath that red one. All right. There are 3 methods to solve systems, and we're going to go through each of these, one per day. The first one is graphing, and you kind of saw that example on the previous page where you look for where it crosses or where they intersect. The next one is substitution, which I'm hoping you've heard of, and then elimination is the last one. This we'll get to later, but just a quick introduction to that. What I do want to emphasize now is how to take a word problem and write it as a system. I'm not going to ask you to solve these yet, but I'm just going to ask us to learn how to write these as a system. All right, here we go. The sum of two numbers is 21. How can I write that? I would write x plus y equals 21. The larger number, let's call it x, is the equal sign. So the larger number is 6 less than twice the small number. Okay, the small number we'll call y. So 6 less than twice the small number. Well, what is twice the small number? That's going to be 2y. And 6 less than is going to be minus 6. And there we go. We have a system. We have two equations. We're saying the two numbers add to 21. And then we're saying that the big number, this x, is twice the small number, but it's 6 less. And I know it says 6 less first, but we're almost always going to put the 6 less or 5 more or whatever it says at the end. All right, next one says the difference of two numbers is 15. So we'll say x minus y equals 15. The larger number, okay, we'll call that x again, is 1 more than 3 times the smaller number. Well, let's call the smaller number y. So the large number is, so that's going to be x equals 1 more than 3 times the smaller number. Well, 3 times the smaller number will be 3y, and then 1 more is going to be plus 1. And again, I emphasize the fact that the 1 more or 5 less or it will always be after that multiplication. All right, it's going to get a little bit easier now. Tickets to the concert were $2.50 for adults and $1 for students. 1,200 was collected and 750 tickets were sold. So let's let A equal the adult tickets. And let's let S equal the student tickets. All right. Well, first of all, 750 tickets were sold. So that means the adult tickets plus the student tickets are going to add to 750 total tickets sold. And then I love how this is so nice. It says $2.50 for adults. So we would say $2.50 for an adult ticket plus $1 for student tickets. So $1 for a student ticket gives us $1,200 total. And that makes total sense because we're making $2.50 per adult ticket and $1 per student ticket, and that gives us $1,200. And the question that they would ask is, well, how many adult tickets and how many student tickets were sold? And we're not going to solve that yet, but we'll be able to do that in the future. All right, last one here. Abby filled her goodie bags with 4 cookies. So we'll say cookies equals C. And then we'll go with candy bars. So candy bars equals B for bars. And spent a total of $10.25 per bag. All right. Marissa filled her goodie bags with 2 cookies and 77 candy bars and spent a total of $14.75. All right, so what we're going to do is C equals cookies, but really it's the cost of the cookies and the cost of the candy bars. So 4 cookies, so I'm getting that from here, plus 3 candy bars, so plus 3 bars, is going to cost them $10.25. And same thing here, 2 cookies plus 7 bars or 7 candy bars is going to cost $14.75. And now we have a system, and we can't solve it yet, but I'll certainly teach you how to do that. That's it, ladies and gentlemen. Hope you enjoyed the video. Have a great day.